Who lives in a place that's warmer than Canberra? Who doesn't? Where do you live? I'm not sure Tasmania's colder than this morning, right? On the ABC website this morning there's a story that says this is the longest run of sub-5 degree days in Canberra's history. And I read it, and I've lived here for 23 years, and I thought, bullshit. That's not true. This is not even close. So I opened up the story and had a look, and it was done by a company called Weather Zone, who've had a station here since 2008. So since history is since 2008, I was relieved. That's a screenshot from the Australian Bureau of Meteorology, your number one resource for those interested in drought. And that's the calendar year annual rainfall for the Murray-Darling Basin over the last 120 years. And you can see down the bottom the low rainfall periods. I think the principle there is if you get two together, you get named. The exception is in the 1960s. I don't know if you realise, but Australia actually has a drought page on Wikipedia. There's only 3 countries that do it. It's kind of part of the country, right? Drought. They sort of go together. You would think in a country like this we would have a really good handle on defining drought. It's kind of pretty straightforward. The last time I looked, there was a major review done by Anne Van Loon in Wire's Interdisciplinary Reviews in 2015, and she counted 200 definitions of drought and growing. So the question is, why is there so many? Why do you think there's so many definitions of drought? Set the context. I don't know if you know the numbers. That's actually consumptive water use in Australia in 1 year. So 70% of the water use is for agriculture, 21% for urban, 9% for other industries. And so the urban is 3,300 gigalitres per year. Now consumptive water use means when you turn the tap on, right? Something comes out the other end. That's what they mean by that. So I'm flicking around a little bit. Why is it so difficult to define drought? Well, it depends on your point of view. It just depends on who you are and what you're doing. If you're a dry land, or you're an irrigation farmer, or you're a futures trader, or you're a manufacturer, it's not really a lack of rain that is the prime impact of drought. It's a lack of money, right? So in a dry land farmer, you get a year of poor rainfall, you get a year of poor yield and poor production. Often the prices are actually higher in a drought year, supply-demand, and you don't have money. And you don't have money because you didn't harvest much crop. Urban is slightly different. It's not so much about money, but it's about function. So you need clean drinking water, water for gardens. Now I'll ask a question. Who in this room has ever gone hungry because of drought? Has anybody ever experienced hunger because of drought? You have? Why is that? Why don't we experience hunger? Because we have lots of droughts. And it has major impacts on agricultural production. Why don't we go hungry? Anybody? Do we? Do we? How much food do we import? A little bit. Not a lot. Actually, the reason we never go hungry because of drought is the reverse. We export. So Australia produces enough. Australia is one of the world's major food exporters. So we export enough. Our total food production would feed about 120 million people on our diet. Right? So when there's a drought, what goes down is the farmer's income, but the people in the city don't really feel it because we produce more than enough food. Just to get the scale of this. So 3,300 gigalitres is the entire consumption of water by all the cities and all the towns in Australia. You add industrial, that's another 1,400 gigalitres. What would that be, by the way? What sort of things would be in industrial? Yeah. Manufacturing, power production, cement production, stuff like that. So this agriculture, 11,400 gigalitres, and this is the breakdown. It's a bit small actually, but this is the breakdown. So this is New South Wales, if you can't read it, Victoria, Queensland, South Australia, Western Australia, Tasmania, and the Northern Territory kind of just gets on the thing. So the green bars are surface water, so that's water that's in dams, and the brown bars are groundwater. So that's water that's extracted out of bores. So New South Wales and Victoria, so that's about 4,000, Victoria about 3,000, that's 7,000 gigalitres between them out of a total of 11. If you add Queensland, it gets up to 10,000. So Victoria, New South Wales, Victoria and Queensland account for the bulk, and nearly all of that is in the Murray-Darling Basin. Right? Over 90% of it is in the Murray-Darling Basin. So just think about this for a minute. It's 3,000 gigalitres for all of the Sydney, Melbourne, Brisbane, Adelaide, Perth, all the coastal towns, all the inland towns. Yet agriculture is 11,400. That's the storages in the Murray-Darling Basin. So this is a thing, this was updated on the 13th of June. It's the most recent one I could get. And you can get these on the Murray-Darling Basin Authority website. And so if it's blue all the way, it means it's full. And these are all the dams in the Murray-Darling Basin. So remember, this is 90% of Australia's agricultural water use, which is 70% of Australia's total water use. So this is basically the major part of the water. So the total, just get this, the total use of water by urban and industrial is equal to Dartmouth Dam. One dam. And all the rest of it is just extra water for irrigation. That same story is played out across the world. It's a little bit different between developed and developing countries, but the general principle, the global average for water, for water use, is 75% of it is used for irrigation across the globe. just one dam stores enough water, just one dam. In the Murray-Darling Basin, this is Dartmouth at 3,800 gigalitres. That's its capacity. It's currently got 3,400 gigalitres in it as of last week. So what happens when Sydney has a water supply problem, or Brisbane has a water supply problem, or most famously Perth has a water supply problem? Why not use this water? Yeah, it's heavy. It's hard to transport. Right? It's in the wrong place. So drought is basically about food production. Right? It's about, in this country, it's about food production and exports. In other countries, there aren't that many countries that export food. The biggest food exporters are the US, Canada, Australia and New Zealand. Right? And recently China actually has started to export food, and Thailand exports some food, but very few other countries do. So you can see it's complicated, and there's so many drought definitions because there's so many different circumstances, and it's not hard to see that your definition will depend on the circumstances. So the lesson from that: drought is complex and it depends on the context. Southwest of Western Australia, best known as Perth's rainfall has gone down. You often hear since the 1970s. Well, according to the Bureau, this is for the standardised region, the southwest of Western Australia. It's not just Perth. It's the whole southwest region along the coast. It doesn't include the agricultural regions. You see that actually what we think of as drought years, there's one, there's one, there's one, there's one, there's one, maybe that one, maybe that one, maybe that one, that one, that one. They haven't really changed that much. Right? The driest years are still about as dry as they were 100 years ago. The thing that's different in the southwest of Western Australia is that there's no wet years. There hasn't been any really wet years since the 1960s. So that's exactly the same data, just presented as an anomaly. And you'll see that there's a trend, there's an obvious trend there. There's more red bars at the end than there is at the start. And that comes about, again, because there's no wet years, or there's been a decline in the number of wet years. Which begs the question, imagine we were going to use the 100-year average to assess drought, and imagine we came up with a definition that said the lowest 10% of years we'll call drought. In that context, we're going to end up with a lot more drought years at the end than at the start, if we use a 100-year average as the baseline. So should we use the 100-year average as the baseline? Let's say we got into a situation where the lack of wet years became so extreme that every progressive year was a drought year, according to our definition. Right? So you think about that for a minute. Imagine our definition, and it led to a situation where 5 successive years were a drought year. Well, you'd have to think that that was no longer extreme, wouldn't you? If drought is the norm, then it's the norm. It's not an extreme anymore. So for that reason, your definition of a baseline is really important. And it's one of the reasons for the fact that there's 200 different definitions of drought, and different people have different contexts for different baselines. So if you're a dryland farmer, for example, the length of the baseline is related to the cash flow of your business. So you think about, imagine you were running a business, an agricultural business, and you didn't know how much money you were going to make each year. And in fact, you could make quite a large loss. The question is, how much money do you need in the bank to be able to go over the peaks and troughs? And that will define the length of the baseline for that farmer. So you can see different people will have different amounts of money in the bank, so they'll have different baselines. So you can't even be sure that one definition is suitable for every person, even within a given industry. Hence, I keep coming back to it, the 200 different definitions of drought. So you could fit a linear trend, right? And you could measure the extremes relative to the linear trend, or you could fit a 10-year moving average and measure the extremes relative to that. Or you could fit some other thing. You're all smart people. I imagine you've got functions in whatever software you use. You can fit anything you like. But this is important in drought. What is the baseline? So the lesson there is extremes are always relative to some local baseline. Okay, jargon. If you're going to get into drought, you can't just call it drought. You have to have a prefix. So this is meteorological drought. It's about rainfall, right? So and the Bureau has a part on their website, recent conditions. So this is the year from 1st of October 2016 to the 30th of September 2017, expressed in deciles. So they make the decision that a decile 1 is very much below average. Anything in the decile 2 to 3 range is below average, etc. And then they have these special categories, highest on record. So those deciles are calculated based on however many records they've got, which in the case of rainfall start from 1901, or 1900 actually. So there's a little bit more than 100 years. So they're not a bad measure. If you're doing 30-year averages, right, you'd only have 3 samples. If you think 30 years takes a climate, is what it takes to define the climate, we've only got 3 climates worth of instrumental records, which is a bit awkward for statistics, to say the least. Another thing about this plot is that's nearly the wettest on record, and that's not quite the driest on record, but it's very much below average. That's common. Right? There's a spatial dimension to this as well. The average across both of those is it's all average. Right? Generally speaking, we get very interested in rainfall, but ultimately rainfall's not the thing that matters. Ultimately it's stream flow. And it would make far more sense to do the deciles on stream flow. The reason that that's not so common is we don't have as much data. Right? This is not data. This is a combination of data and modelling. This is for exactly the same period on the Bureau website on the water part of the website. So you see that the stream flow here was very much above average and the stream flow here was very much below average. But stream flow is the thing that matters because that's what flows into the surface water. And surface water currently makes up the dominant part of the extraction. Groundwater is a much smaller component. Okay? So when you think of drought, from the point of view of water supply for irrigation or water supply for cities, it's actually hydrologic drought that you're interested in. So these are the different perspectives. For those of you who don't know, as a result of the Millennium Drought, which depending on who you ask, started in 1998 or some people say 2000 and it finished in the middle of 2010. So it went for 10 years. Interestingly, I'll just go right back to the start here. It finished with that year there. So it actually finished with the wettest year on the record, right? Which was followed by another wet year. If you have a look, there's actually only 2 really dry years in the Murray-Darling Basin over that 10-year period. So how come it's called a Millennium Drought? There was only 2 drought years out of 10. And the reason is it's kind of the same as Perth. There were no wet years. Right? It wasn't that the dry years were drier than any other. This year was the driest of the lot. It was that there were no wet years. And that's how droughts get longer. There were lots of years with average rainfall through there, but you can't really break a drought with average rainfall. Right? You've got to have extreme at the other end. It used to be the case that before the Millennium Drought, that cities like Brisbane, Sydney, Melbourne, Adelaide and Perth would be constantly monitoring the dam supplies. They're constantly monitoring how much people consume. It's a balance. Are we going to make it through? The classic example this year was Cape Town. And I don't know what the current status. Does anybody know what the current status of Cape Town is? Did they run out of water? Damn good. So they escaped. Right? The central question for drought studies, the central application for drought studies in non-irrigation or non-agricultural things is how often will I have to run my desal plant? Brisbane, Sydney, Melbourne, Adelaide and Perth all have desalination facilities now, which makes up the majority of the population of the country. So Perth's desalination plant, there are 2, and they're completely operational, and Perth is completely dependent on them for its water supply. Only 20% of Perth's water supply comes from surface water storage. 80% is from desal or groundwater extraction. Adelaide, Melbourne, Sydney and Brisbane actually haven't needed to use them since they built them, which always happens. If you're an engineer involved in water supply, an old engineer once explained to me, the way to break a drought is to do something about it. Right? You decide, let's build a pipeline, and then it rains. And then you get hammered for spending all this money that you didn't need. Personally, I don't think they're bad decisions because the population is growing. The only question is when are you going to need an increased supply? So currently, Adelaide has brought their desal plant out of mothballs and they're operating it at a background rate. Melbourne is actually operating at 100 gigalitres a year at the moment. Sydney, it's mothballed, and in Brisbane, it's mothballed. Right? So it would take a year to get the one in Sydney and the one in Brisbane operating again. But that is really the key question. For agriculture, the key question is runoff. Right? It's not rain, it's runoff. Now you can say, oh yeah, but the runoff comes from the rain, and that's true. Right? But the runoff is not the same as the rain. There are a whole lot of processes in there that modify it. And this is the thing. You think, so what I'm trying to do here is to get you to think about what do users of the information that you produce, what do they do with it? So if you're an engineer involved in water supply and you've got a drought, the standard approach to that before 2000 in this country is build a bigger dam, store more water. Right? In Australia, we try and store 5 years of water supply, urban water supply, in our storages. Does anybody know what it is in the UK? A few months. Why is that? Why do they don't store any water and we have 5 years of storage in the dams? Exactly. So the UK can actually have a severe drought with a few weeks where it doesn't rain. Right? We have a few weeks where it doesn't rain. We have more barbecues. Doesn't worry us. We've changed the inflow by adding desalination, and we're starting to use groundwater more. Another way of managing drought is to say to the users, you can't use as much water as you could before. So who's lived through water restrictions? Yeah, what happens? Anybody? Short showers, right? Shower with a bucket, shower with a friend. Right? It's my favourite. Yeah, there are all sorts of restrictions of use. What they're trying to do is preserve the water, and basically they're adopting the scientific approach of praying for rain. Right? These are the only management options that people have got available. So if you write a paper and say, I think there's going to be a lot more drought in future in Australia, and people take it seriously, then what they're doing is they're thinking, well, what can we do? Right? To avoid that. Agricultural drought. This is by far the most difficult because it's not related to a single thing like stream flow or rainfall. In practice, this person standing here is ultimately worried about their net farm income because we're in a market-based economy. Not everybody is in a market-based economy. So in those cases, it's something quite different and much more complex. But in a market-based economy, the net farm income is a function of your production, so the yield times the area that you've got planted, and it's a function of how much money you get for that production and how much it costs to produce it. Right? So this person here is actually managing a fairly complex set of interacting variables. Some of them are biophysical and some of them are socioeconomic. We tend to think of drought as causing a drop in agricultural production, and that's true. This was a study released in the about a year ago by the Australian Bureau of Agricultural and Resource Economics. It's actually a really good study, and I would recommend, if you're interested, go and have a look. What they found was that just considering climate alone, the Millennium Drought caused a drop in agricultural production of 10 to 20% over that decade. But the same study also found that the overall profitability increased dramatically, right? And what was really surprising was the profitability went through the roof after 2006. Now, for those who don't, 2002 and 2006 were the really low rainfall years in that Millennium Drought sequence. So the year after that second really dry rainfall, agricultural productivity just changed. Why do you think that is? I have no idea, and the people who wrote the study didn't have any idea either. Yeah?
2006 and 2007, they changed the species include a number of other things too. Much more drought hardened version, and it increased yields for the same amount of rainfall.
People adapt, right? You can imagine the situation. It's dry, it's really dry, it's average, it's really dry. People would be sitting around the kitchen table thinking, I've had a gutful of this. Something's got to change. The other thing that happened is a lot of the farms which had low capital available actually went out of business. And they were purchased by farms with much more capital, right? Capital is the thing that enables you to ride out the bad years. Some distinguished agronomists have even argued that drought is the thing that drives innovation. Without drought, you don't get people innovating, which kind of makes sense to me. So the lesson, there's socioeconomic and biophysical settings, and humans can and do adapt. If humans can and do adapt, what baseline should you use? It's kind of an awkward question, right? Okay. It's one of my favourite things to do. If you're interested in something, a generic thing, climate change, go to Google and put climate change into Google, and then hit the image tab on the top and pick the first image. And that's pretty much, in my experience, that's pretty much the way the public see things. Now, if you do that, probably you can do it right now. I think Nikki's about to do it. That gives you a feel for what the general perception is out there. If when I did it, that's what I got. The problem is, which side's climate change and which side is not? What do you reckon? Sorry? Which is that the current state of the world and that's climate change, or is that the current state of the world and that's what we're going to get with climate change? Which one is it? That's what? Okay. Actually, it's not today here. Yeah, I think that is what most people in the public think. I know that you're more sophisticated than that, but that is what most people think. How'd you go, Nikki?
Yeah, it's the same.
Yeah. It's been the same for about 4 years.
The 10th image is the same image but flipped.
Really?
Yeah. So the hand's coming in from the right.
And the perception is, you all know this, CO2 is increasing phenomenally. That's the year that I started university, right? when I was an undergraduate. It's now 20% higher. It's kind of unbelievable it's going so quickly. This was a paper that was published in December last year in Nature Climate Change, and the idea was with the Paris targets to keep warming under 1.5 degrees, how long will it be before general aridity emerges? Right? How long will it be before we can see it? And what they say is if the emissions follow the RCP 4.5 scenario, which they're not, so I'm not even going to talk about it, the emissions are following much more closely this one. This shows that by 2030, large areas of the world, we will be able to see an emergence of the right-hand side, right? That world of pain, basically. There are hundreds of studies like this. There are hundreds, not tens. And it's just only a matter of time before everything gets more arid, more drought, right? Kind of makes sense. All of the studies, including that one, which do this, have a methodological flaw in them. And they all use some sort of index. Martin's going to talk about this later. There are a whole range of different indexes. But what they actually do is they go to the climate model output. Now what you could do is go to the climate model output, get the projected hydrology and analyse that. But they don't do that. They go to the climate model output, they do all this complicated stuff, but they calculate a quantity called potential evaporation. And then they make a projection. And that projection, it turns out, is actually not the same as the projection from the climate model output. They've changed it, right? So it's not fair, and then they write a paper saying this is what climate models say. And this paper is in that category. That result is actually not what climate models say. It's what this line of reasoning produces. If you want to follow it up, there's a beautiful article by Chris Milley and Krista Dunn in that journal where they explain this in great detail, and I explained it in a more generic way a few years ago. Right? The single most important thing I'd like you to remember, or two, one is water use is all about irrigation, and two, if you want to make projections using climate models, then use the climate model. Don't use another model, because that's not the same thing. This particular thing has caused more problems than you can imagine. If you want to make a projection with a climate model, you've got to go back and think about the underlying biophysics of the system and how water and carbon are coupled. And that's how climate models represent it, right? So you have a flux of precipitation, you have a flux of evaporation. Some of the evaporation is transpiration, so that's evaporation that goes through the pores of leaves, stoma, or stomates, the plural. And that leads to photosynthesis, or that's associated with photosynthesis in a very tight coupling. Then there's evaporation that doesn't go through leaves, so that's off soil, off dams, off wet canopies, etc. And then there's runoff, and then there's soil storage. The really important thing to understand about increasing CO2 is increasing CO2 changes the relationship between transpiration and what I've called assimilation here, which you would know better as photosynthesis. And it changes the relation in such a way that for a given amount of water that's being transpired, at higher CO2, you'll assimilate a lot more carbon, right? Or in reverse, if you want to assimilate the same amount of carbon in a higher CO2 atmosphere, you'll use a lot less water. So from a plant point of view, increasing CO2 is actually a reduction in aridity, just of itself, right? And the effect is actually big, because the CO2's gone up a lot. And the mechanism for that is related to how CO2 and water are exchanged right back at individual leaves. And it's reasonably well understood. So, at the same time that there are papers saying the world's going to get more arid, and that image comes up, right, of a beautiful, pristine world and a world that's burning up, at the same time, there are a whole range of papers being written saying the Earth is greening and CO2 did it. There's a kind of dichotomy there, right? You can't have it both ways. And in this particular paper, and Martin's going to talk about this in a lot more depth in the next talk, this particular paper said most of it is just because there's more CO2. So which side is now and which side's the future? Because according to climate models, the future is greener. It's kind of weird, right? Just to give you a bigger feel for it. This is a study that I initiated, and it was done the sort of thing you can do in a centre. Peter Grieve was a PhD student at ETH, working with Sonia Senavaratne, and I met Peter. We had coffee. We had a long discussion. We said, let's do these two papers. So we did them. So I did one and Peter did one. This is a study going right back to the last glacial maximum. So 20,000 years ago, when the CO2 was 180 parts per million. Now, one thing I can tell you from my own experience, if you try and grow an ordinary plant, so a wheat crop or a tree or anything like that, at 180 parts per million, basically they hardly grow. I've done it myself. They can barely make the reactions go forward. Right? C4 plants like corn are a little bit different. They can actually grow, not so well, but they can grow at 180 parts per million. But trees really struggle. And they struggle because they've got to use an enormous amount of water just to get a little bit of carbon. Right? That's what comes out of this study. These are climate models. There were 6 of them. And what we've looked at is the difference between current conditions and the last glacial maximum for precipitation, for runoff, and then we've added relative humidity. And you see for Australia, Australia is currently believed to be, according to climate models, we have more rain than we had 20,000 years ago. And we have more runoff than we had 20,000 years ago. This is going into the future. 4C means 4 times CO2. So it's roughly 1,100 parts per million. And that's roughly expected at current rates to be about the year 2100. Right? Maybe a bit after. And in that case, according to these models, the north gets slightly more rain, the south gets slightly less, the north gets slightly more runoff, the south gets slightly less. The relative humidity goes down over large areas of the planet. Just a small drop. This is the story from a vegetation point of view. So this is from the last glacial maximum now, minus the last glacial maximum. So nearly the whole planet has higher photosynthesis than it had 20,000 years ago. By the year 2100, if you believe these climate models, and Martin will tell you a whole lot of reasons why you may not, but if you do, the photosynthesis is expected to go through the roof. And it's not because the plants are transpiring more water. It turns out that in the climate models, plant transpiration actually goes down ever so slightly. What it's because is the water use efficiency of photosynthesis increases everywhere. So those models are projecting a story of a greener world. Maybe not as much surface water, but certainly greener. Which is very different from that image, right? Just out of interest, if you're ever in the area of Winton in central Queensland, you can... If you're ever in the area of Winton in central Queensland, currently in drought, so you might be interested, there's an amazing dinosaur stampede. They've built a complete shed over it, and it's all the footprints of these dinosaurs that were... Little dinosaurs were running away from big dinosaurs very quickly, and they left these footprints. And it's a wonderful place to visit. But as you walk up the gantry going into this, these are the things that you read. And if you read in Mary White's book, Gondwanaland, that's actually on the first page. Low atmospheric CO2 has always been thought of geologically as being cold and dry. And high atmospheric CO2 has always been thought of as being warm and wet. Right? Anybody who's interested in vegetation, I would suggest spending a little bit of time on YouTube. There's a very famous study done in South Australia, a long-term vegetation study, and they've done repeated photo points. In the early years, every year. In recent years, sometimes as every 5 years. They've gone back to the same point in an arid environment in South Australia and taken exactly the same photo for about 160 sites. And Dean Grates, who's a distinguished ecologist, actually a graduate of ANU, he got all those photos, scanned them, and put them in as videos on YouTube. And you can sit there and you can watch the vegetation change over the last 100 years. It's quite extraordinary. The stuff I talked about the CO2 and whatever, is all about aridity. Aridity is not drought. Aridity is like the background, how wet or how dry you are. Drought is the extremes around it. All of those studies don't actually say anything about drought. No? Because for drought, again, you've got to look at the extremes around the background. So the lesson, if you look at climate model output, globally, in general, they're projecting a warmer and wetter world. But these are projections, they're not facts. Right? The behaviour of vegetation is central to both aridity and drought. Right? And research is really only just beginning on extremes, or particularly hydroclimatic extremes. This is what we started with. When you make a statement about drought, think about what people can do as a response. If you're an Australian farmer, say you're a farming family at Wagga, and you're currently wondering whether you should plant a crop this year or not, because they haven't actually planted in Wagga at the moment. And the decision is about $2 million, which you have to borrow to buy the seed and the fertiliser and put the petrol in the tractor or the diesel. The question that dryland farmers in this country face predominantly is how much money do they need to have in the bank? Right? That's the central question. So if you're saying, well, I think drought will be bigger, what you're really saying is you need more money in the bank. Because that's really the only management thing they can do. It is the only option they've got. Similarly, if you're the senior water supply engineer for Sydney Water and someone from the ARC Centre of Excellence for Climate Extremes says there's going to be more drought, it's actually not so serious for them because they can wait and see what happens. But in the case of Sydney, from the current state, it would take a year to get that desal plant operating. It's why so many people operate them at a background level, because then you can crank them up really quickly. So if you say that if Sydney is going to have an expanding population and they're not going to have bigger dams, and there's no indication that they're going to, the only option is to actually fill the dams up more than the rain, which is desal. And if you then say, well, there'll be more drought, it just means you run the desal plant longer. Right? Or you have a bigger desal plant, which is what Perth has done. The point of this is, what you're doing is actually serious. It's not an academic game, and it affects real people. And in the case of drought in this country, it is seriously real. Because our droughts are sort of part of the landscape. So just take a moment of thought to think about how people can use the information that you produce. Any questions? Or comments? Who thinks the world's going to be which is the future and which is now? That's squibbing it.
Depends where you are.
Yeah.
And it's already changed. Anyway, the left is no longer the present.
How has the left changed?
We've already warmed up.
But that doesn't show warming, right? The left.
No, that's what I'm saying. It doesn't show it. That's the past.
Question about the measures like conserving water in time of droughts. And the Cape Town case is the most recent one. It's the same there, 75% are used for agriculture. So what is really the point of saving water in the city and hurting like tourism and so on, when it's only not even 20% of the total water consumption?
Good question. In Australia, it turns out that our cities are along a thin bit of the coast and our agriculture is not. So the water supplies are nearly completely separated. The only place where it's not is Adelaide. And you often hear Adelaide squawking about the behaviour of upstream states. Right? But everywhere else, Sydney Water does not share any of its water with agriculture at all. Nor does Brisbane, nor does Melbourne. In fact, in the drought in 2007, there's actually a pipeline from Shepparton to Melbourne, and it was briefly proposed that water would be transferred out of the Murray-Darling Basin and into Melbourne's catchment, because it's actually a separate catchment, right? Well, I thought there was going to be a war in Shepparton, and the idea went away by the afternoon. It just disappeared. But there is a pipeline there, and there has been there for a very long time. But water has never been transferred from agriculture to cities in this country's history. It's like there's two worlds now, actually.
What are the differences between these two methodologies for interpreting the climate model output? So one gives you validity and one gives you grading.
What are the
Differences between the methods that produce such radically different results?
So the climate model output, if you wanted to see whether something was greening, you'd look at a measure of vegetation productivity, right? So you'd interrogate the climate model output for a measure of vegetation productivity, and they've all got it in there. If you don't know about this sort of stuff, it'd be called something like GPP or NPP, something like that. What the other methodology does is it usually forms a ratio of precipitation to a quantity called potential evaporation. And the quantity that they call potential evaporation is calculated assuming that CO2 has no effect on vegetation. Right? But it actually, CO2 does have an effect on vegetation, so you can't calculate it that way. So the safest thing to do is just look. So if you wanted to know about runoff, just get to the climate model output, and if it doesn't have a runoff field, calculate it from mass balance. So precipitation, less evaporation, less change in soil storage will give you the runoff. Right? Does that answer your question?
Yeah, I think so.
Martin's going to go into this in much greater detail in the next, starting minus 5 minutes ago. But I started 5 minutes late, so now we're on time. And the temperature's probably above zero outside, so I can leave. No more questions?